Hi, and welcome back to The Joy of Ray Tracing, a video series in which we make several ray tracers from scratch. On the last episode, we successfully moved all the CSS information and JavaScript out of the HTML document and into their own separate files. We took a brief look at CSS and how to apply stylings to the elements on our web page. But today, we're going to take a look at one of the most important components of web development, and that is the JavaScript programming language. We're going to start by experimenting with JavaScript inside the browser's console window. Then we'll take a look at how we can use our new knowledge of JavaScript to make our web pages more interactive and responsive to the user. So here's what we're going to do today. Today's to-dos. First, I'll show you how to open up the Inspector or DevTools window inside your browser so that we can start exploring JavaScript. Once we're in the DevTools window, we'll gain access to the JavaScript console so we can start typing JavaScript. We'll then use the console to explore the basics of JavaScript, and we'll start typing some short JavaScript snippets into the console, and the browser's interpreter will give us immediate results and feedback. While we type our snippets into the console, we'll take a look at some of the main aspects of the JavaScript programming language, and we'll focus on ones that we need for our ray tracers in the future. Using our new knowledge of JavaScript, we'll go back to our simple web page and add some event listeners that will link up the JavaScript and our HTML document so that it'll give it some responsiveness and interactivity. In particular, we'll add one of the most important event listeners, which is called the window resize event listener. And that will quickly respond to a user's actions if they happen to change the size of the window while our application is running. And that includes the situation where they're on a mobile device and they change the orientation, like from portrait to landscape. It'll update immediately. So let's get started. So let's open up Visual Studio Code. And it should open up to what we were working on last time, which was the style canvas.js file. So to start experimenting with JavaScript inside the browser, let's go inside styled canvas.html and go ahead and open up that with your live server. So you remember it's down here on the right bottom corner. Go live, click that. So here's what we were working on last time. We had the text output here, and we had 5 rectangles, 1 in the middle and 4 in each corner. So what we want to do now is gain access to the JavaScript console. And so on most browsers, you can do that by simply right-clicking anywhere on the web page and clicking on Inspect. So that will bring up your inspector. And before I get to the console tab, I need to take a small detour for the Mac users out there, because if you're on Safari, this option won't come up right away when you right-click. The DevTools are not enabled by default on Safari browsers. So let's take a look at how to enable your DevTools inside Safari so that you can get into the console and start typing JavaScript along with us. So I'm going to minimize this and get to my desktop. Now I have some good news and bad news for you Mac users. The good news is I will be able to exactly show you the steps necessary to get the DevTools enabled in your Safari browser. The bad news is that since I'm on a Windows device, and since I don't have any Apple devices available for demonstrating these steps, I have to use a slightly older version of Safari to show you these steps. That version is 5.1, which was made back in 2012. So get ready, we're gonna go back in time about 10 years. So I'm gonna open up Safari on my Windows device. That's nice that it goes to apple.com. Oh wow, the new iPhone 14 is out. Wow. I wonder why they skipped so many numbers. Oh, and by the way, the reason why this web page isn't loading correctly in this old browser is because the web page itself probably uses a newer version of JavaScript and all the latest, greatest web technologies and APIs. So if I try to right-click and inspect this page like we did a moment ago for the Brave browser, you'll see you can't really inspect. There's no option for that. And to get the inspector to show up when you right-click like that, it just requires a couple of steps. And even though this version of the Safari browser is over 10 years old, all the steps are exactly the same, with one small exception. When you go up to the left top corner, you'll see I have an edit option up here in the menu. On your browsers from the future, you'll see the word Safari. So click on Safari, and now this is where it's all the same between my old browser and your latest, greatest browser. So go down to Preferences and click on that. And then it'll probably open up with the General tab. And so we want the tab all the way to the right, and that's the Advanced tab. It has a gear icon, so click that. And then down towards the bottom of this tab, you'll see this option, Show Develop Menu in Menu Bar. And as soon as I click that, watch up here and a Develop option will pop up right in the browser's main menu. So 3, 2, 1, click. And then you see Develop showed up. And when you see that option pop up, you're good to go. So now you can go back to your web page and right click, and it should show you the Inspect Element option. So let's try that now. So click out of Preferences and then right click anywhere on the web page. And now we have a new option, Inspect Element. So if you click that, it'll bring up the inspector, and then you just find the Console tab. So when you click on the Console tab, you can start entering JavaScript into this console, and it'll immediately give you results from the interpreter. So I can type some numbers or some calculations or some expressions. So 5 plus 2, enter, and it should give me the immediate result, just like a calculator would. But one thing to note on this older browser is if I use the let keyword to define a variable, it won't work. So let my variable equals 5. And you see I get an error. It doesn't understand the let keyword because that didn't exist in the JavaScript programming language back in 2012. So back in the old days, we did it like this, var, which is short for variable, and that will still work in modern day browsers as well. Var my variable equals 5. And that appeared to work, so we can type my variable, and it should give us back the number 5 that we stored in my variable. So this was a fun trip back in time, but now it's time to head back to the future. So I'm back on styledcanvas.html. That's the web page we were working on last time. And hopefully at this point, all of you out there can follow along with me no matter what device you're on, Windows, Linux, or Mac. So let's all right-click now anywhere on the web page and click on the Inspect or Inspect element, whichever you see. And if you've never played around with the DevTools before, it'll probably open up on the right side of your browser window. Typically, I like to have mine on the bottom. So if you go to these three dots right here, click on that, and then you can dock to the bottom. And usually that's how I have it, so I can enter things in the console here and then see them in the web page immediately. But for the purposes of this video, and so you all can see what I'm typing into the console, I'm going to undock it and put it in its own window. So undock. And sorry about that blast of white light. Let me try to fix that. So if you click on this little gear icon here, you'll see a theme option, and then I'm going to click dark. Whew, that was close. My eyes were starting to melt. So now you can click this little bit, not this big one, but this little bitty X here. Now we're still in the web page inspector, which will show you all the source code that we typed in to create our web page. So you can see the canvas element called myCanvas. You can see the paragraph element called myText for the text output. But what we want for today is the JavaScript console. And so if you click on console, that'll put you into the JavaScript console mode. And again, so all of you can see it better, I'm going to increase the zoom. So control mouse wheel forward. And to start with a fresh console, we can click on this icon here, which is like the no symbol. So click on that and it'll clear up the console. You can also do right-click, clear console. Before we start playing around with JavaScript, I like to mention that this console inside the browser has a real-time interpreter. And so if you enter an expression or code into the console, it'll get read and parsed by the interpreter, and then it'll get run immediately. JavaScript is a dynamic programming language, and it needs a host environment in order to operate. So whereas with older languages like C or C++, you would write the code, then you would compile it into an executable that would be in machine code for your particular machine. And that way you could open up the application on your desktop or wherever you have it. But with JavaScript, it runs in real time in the host environment. And 95% of the time, the host environment is just your browser. So all browsers nowadays ship with JavaScript interpreters and JavaScript engines that optimize your code, and even just-in-time compiling or JIT compiling, JIT, and that means that it takes the code that you write, quickly analyzes it, optimizes it, and then spits out the machine code on your particular device, which will run much faster than if it was just running from the interpreter. So to start our journey into JavaScript, let's just try entering some simple numbers and expressions into the console. So I'm going to type 5 and then hit enter. And so it gave me back the value 5. So this is known as a constant expression. It never changes. You can't change the value of 5 to anything else. Let's try some mathematical expressions. So 5 plus 2. And you can see right here, it evaluates that quickly as you're typing. And if you hit enter, it'll give you the value that is expected. So 5 plus 2 is 7. So in this way, your computer acts much like a calculator. And so you can do any mathematical expressions that you like. Let's try some more complex expressions. Let's try 6.745 divided by 3.28. And again, it acts much like a calculator would. JavaScript has all the mathematical operators that you would expect. So plus, minus, times, divided by. So 2 plus 2, or 6 minus 3, or 7 times 4, or 8 divided by 2. Again, it acts much like a simple calculator at this point. Now, if that's all computers could do, what would be the point, right? We wouldn't even be here. So what computers have to offer is they can store values like these in memory, and you can have the computer go and get those at any moment. So let's clear the console, right-click, clear console. And now let's get some practice creating some variables that will hold numbers. And by the way, JavaScript only has one number type. So in other languages, you can specify integer or floating point, which can have a decimal or fractional part. But in JavaScript, all numbers are the same so far as the memory is concerned. So do you remember how we created variables in our program last time? So it's the keyword let, L-E-T, and then let's just name it A, and then you put the equals sign, which assigns something to it, so equals, and let's just do 5 for now, and then the semicolon. Remember, in JavaScript, we end our statements with semicolons. So let's hit enter, and now you think it would give back 5 like it did earlier when I just typed 5, but this is a variable assignment, so it's putting something into that variable, and I didn't tell it to give me anything back. All I did was request that the computer make a variable in memory somewhere where I can store a value like 5, and I called it A. So if we type A now and then hit enter, we get back what we put into it, so A is 5. So now that the computer has stored the value 5 in the variable A, we can use A wherever we like. So let's try 7 plus A. And that gives us 12 because 7 plus 5 is 12. So now let's create another variable that holds a floating point number, or a number that has a decimal or a fractional part to it. So let B equals 6.49, and then semicolon, because it's a statement. And again, we get undefined back, but we just ask the computer to reserve a variable for us where we can store a value. So now if you type A plus B, we'll get back the sum of those two variables. Let's clear the console again. When you're declaring a variable and assigning a value to it, the value on the right side of the assignment can be as complex as you like. So, for instance, let C equals 4.76 divided by 3.21 times 8.9765. I'm just doing some random numbers, minus 2.11. So I don't know off the top of my head what that's going to be, but let's find out. So if you just type C, so that's what C holds now. And now in most consoles, you can get back to what you typed a moment ago by hitting the up arrow on your keyboard. So try the up arrow one more time, up arrow, and then it gets you back to what you typed a moment ago. So that's really handy. Now we can go in there and change some things. So as you learned in math class, there is an order of operation precedence. So typically multiplication and division gets done first, and then addition and subtraction get done later. But let's say that you really needed this subtraction to be done first, and then you want the result multiplied by whatever this is. And again, like you probably learned in math class, is that you put parentheses around the expression that you want evaluated first. So let's put an opening parentheses before the 8 and a closing parentheses after the 1 here. And now when the interpreter reads this, it'll do this first because it's in parentheses, then it'll do the other operations, and then finally it'll stick the result back into C, your variable that you want. Oh, and I forgot to put the semicolon. So let's see what that does. Now let's type C again. You can hit the left arrow. So now C is slightly different because we did the operations in slightly different order. Now for more complex mathematical operations like sine, cosine, exponent, square root, JavaScript actually has a math object that you can call into. So it's kind of like a math library, if you will. And when you call it, you can use its more complex math functions. So how you access that is you type capital M, A-T-H, and then dot. It'll show you all the math constants and functions that you can use. So, for instance, cosine or floor. Let's try that. So click on floor, and that will round a number down to the next integer. So 5.67, and it rounds down to the nearest integer, so 5. Math dot, and then try square root. So it gives you the square root of 2. The built-in math object also has some useful constants that are important in the world of math. So math dot pi, it's capital P, capital I, and it'll give you pi to this many digits. Let's clear the console so we can get back up to the top. And so something that I use a lot in my graphics programming is I need to have the value of 2 pi. So what I do is create a variable. So type let, and I'll call it 2 pi equals math dot pi, then times 2. Semicolon. So now the variable 2 pi should hold the math object's pi constant times 2. So let's try that out. Type 2 pi, right arrow key, and then enter. And there we have it, 2 pi. And it's accurate to quite a bit of decimal places. So now wherever my program needs the value of 2 pi, I can just type that and it'll put that in for me. Now, before we move on to strings of text in JavaScript, I like to take a moment and go over the stylistic convention that I use to name variables. And that is called lower camelCase. So when I do stuff like let my number equals 5, the first word starts with a lowercase letter, and then there's no space, and then the next word starts with an uppercase letter. And so this is known as camelCase, which has, if you notice, it has like a hump shape in the middle. And so you can do that as many times as you need to. So let's make a really long variable name. Let player score after last level equals 1000. So you can go nuts with this camelCase convention, but the main point is that if you have a multi-word variable name, then you start the name with a lowercase letter, and then every word after that starts with an uppercase letter. So let's clear the console now, and let's move on to strings of text in JavaScript. So basically, a string in any language is just a string of characters, and most often it's words or sentences and things like that. So let's just get some practice creating some string variables. Again, we use the keyword let, and I'm going to do camelCase my string. So it has a small m but a big S for the next word. Space equals. Now for all strings, you must enclose them in quotes. It doesn't matter if it's single quotes or double quotes, but it has to be consistent. So let's try double quotes. Now inside the double quotation marks, let's type, "This is a string of text." And then remember the semicolon at the end of the line. Again, it comes back undefined because we didn't ask it to give us anything. We just asked the computer to store this string of text inside a variable that we called myString. But if you type myString now, it'll come back to you, so this is a string of text. And at any time, if you need to check the data type of a variable, you can type type of, and then your variable name, so myString. So type of myString, that'll return what data type it is, according to JavaScript. So that is a string, or a string of characters. Likewise, you can do, let's try the up arrow key. So that'll bring back type of myString, and then erase that and put my number. And that should come back number, because my number was 5, I believe. My number, yeah, that was 5. So getting back to strings, now let's see some cool things we can do with strings that will help us in the future when we want to print out more complex phrases. So let string 1. Oh, and by the way, you can have a number inside the variable name, but it can't be the start of the variable name. It can be in the middle or at the end, but it just can't start off the variable name. So let string 1 equals, let's do hello quotation and then semicolon. And then now let's make a string 2. So let string 2 equals, you probably know what I'm going to type, right? World. And then semicolon. Let's clear the console one more time. And so now if we do string 1, it should give us back what we put inside the string 1 variable, so the word hello, and then up arrow key gets us back to string 1, and then we erase that and put a 2, we should get the other word, which is world. And that was the other string variable that we had created. And now a cool thing in JavaScript is you can combine these into one string. So how you do that is string 1 plus string 2. Enter. Hello world. Well, there is a problem. There's no space between the two words here. So let's go back and change our variables to put a space in there so it'll look right. Let's go to string 2. I'm pushing the up arrow key to get back to that. String 2. Now you can, in JavaScript, you can redefine variables. So now I'm just going to set it to something else. Quote, semicolon. And then now let's type a space first, then the word world. We'll add an exclamation mark too. Okay. So now let's put those two strings together. String 1 plus string 2. And now it comes out right. Hello world. This process of combining two strings like that is called string concatenation. And that's just a fancy word for sticking them together. Likewise, we can put that result into a variable. So let greeting equals string 1 plus string 2, semicolon. Okay, and then if we type greeting now, it should give us back that phrase all together. There we go, hello world. So let's clear the console again, just to get back up to the top. And now let's move on to the array object in JavaScript. And basically you can think of an array as a list of values. Usually they have the same type of value in the list, but in JavaScript you're allowed to mix the types inside the list. I don't really recommend doing that though because of performance reasons. It's better to have all the items in your array be of the same type. So let's get some practice making some arrays. So and I'm going to use camelCase here. So my array equals, and how you create an array in JavaScript is by using the square brackets. So the left square bracket and then the right square bracket. So left square bracket. And now you can put any values you want inside the array, and they could be of any type. Let's start off with some numbers. So we'll just do, how about like odd numbers? So 1, and then you separate the items in the array by a comma. So 1, 3, let's do all the odd numbers. So this is basically just a list of odd numbers. Now when you're done listing them, you type the right square bracket, and then don't forget the semicolon. So now my array holds all these values here. And so if you type that back into the console and hit enter, it'll give you the list back, and also it'll give you how many elements or how many items are in the array. So we have 1, 2, 3, 4, 5 items, and it says that there, 5. And if you click this little arrow here, it'll list them. Here's the numbers. The length is how many elements you have in the array. So since we have 5 numbers, it has a length of 5. Now, I wanted to show you this because this can be confusing, especially for beginners if you haven't had a lot of programming experience. JavaScript uses a zero-based indexing system. And so what that means is when you want to refer to a list like this, the first element is indexed with the number 0 instead of the number 1. So if you had to retrieve this number here, you have to use this index number to look it up. And likewise, let's say if I wanted to get the 9, I would have to use index 4 for that. And the reasons for having a 0 base index rather than a 1 base index are that this variable, which is an array, is located at a particular address in memory. And when you ask the computer to go retrieve it, it goes to that spot in memory, and then it says, how many more steps do I need to take to get to the value that you want inside this big long list? And so you can think of this number as an offset from the beginning. So this number 1 is in the first spot of the array, but how far is it from the beginning of the array? Well, it's not any distance at all, it's 0. So you can look at that as it's 0 distance from the beginning. And then this is 1 element distance from the beginning, 2 elements distance, 3 elements distance, and 4 elements distance away from the beginning. But let's just try some more things with arrays to get a feel for that. Let's do a new array. So let my number array, and see how I use the camelCase there, equals, and then we denote the array by the left square bracket and the right square bracket. So left square bracket, and let's do all the numbers in order from 1 to 10. And now right square bracket and semicolon. And if you type my number array and hit enter, it'll give you those back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And let's clear the console. And get my number array back so we can see it. So now if I want to retrieve a number from this array, I have to give it an offset from the beginning of the array. So let's say I wanted to get this very first number, the number 1. So I type my number array. You can click on that to fill it in. And then we access that element by typing the left and right angle brackets again, like this. But this time we put the index number. And remember, JavaScript starts indexing at 0. So type 0, and it should give you 1, which is the very first element in your array. We can likewise check the length of the array. So dot length, enter. And it says I have 10 elements in my array, so 10 items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one more thing to note is that a quick way of accessing the last element is to take the length and just subtract 1. So let's say that you had a really big list of numbers and you don't know ahead of time how big it is. So it might be dynamic. The user might be typing all these numbers in. And so you have to find the very last element. So how would you do that? Well, if you type my number array dot length and then take off 1 from that, you get 9. So that should be the right index number. So remember, it starts at 0 for indexing. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you index it with the number 9, you'll get the 10th element. I know it's a little confusing, but let's try it out. So my number array, left square bracket, and then type my number array again, and we're going to get the length, so dot length. Now let's do an experiment here. I'm not going to do the -1 and see what happens. So right square bracket, and you can see it comes up undefined because that is equal to 10, and we don't have that many indexes in this array. So that spills off the end over here. It would be to the right of the number 10 here. So let's try that again. Hit up arrow and put a -1 in the little brackets here. And now hit enter, and we get, yay, we get back our number that we wanted. So we get back the 10th element. So that's a quick way that you can access the very last element, especially if you don't know how many numbers it has offhand. Arrays are very useful because you can quickly loop over them and iterate over all the elements in the array and perform some kind of operation on each element, or you can make some kind of calculation that requires all those numbers in a row. Let's clear the console again. And now let's make an array of strings. So let's do an array of colors. So color array equals, and remember for arrays, we have to use a left square bracket and the right square bracket. So left square bracket, and then let's do the colors of the rainbow. So, and remember each item has to be in quotes because they're all strings. So red, and then close that up with another quotation, comma, and each item has to be separated by a comma. So the next one is orange, yellow, green, blue, and violet. And when you're done listing all the elements that you want, you do the right square bracket and then semicolon, enter. And now my color array holds all of these strings in the variable. Now let's say I wanted to get back the first color. So you remember the indexing starts at 0. So that's going to be element 0. So type my color array, and you can click on it if it pops up. Left square bracket, 0, right square bracket, enter. And then it gives you back red. And likewise, let's say I had more than just a handful of colors and I wanted to get the very last one. You remember how to do that, right? So my color array, left square bracket, and then type my color array again. You can click there. Find the length, so dot length. And that's too many, so we need to bring it back by 1, right? So -1, and then right square bracket. And we get the last element of the array, which is violet, which is correct. One more thing to note before we move on to objects in JavaScript is that the array in JavaScript is actually an object also. And because it's considered an object, it has properties and it has methods or functions that you can call on it. So let's try one of those now. Type my color array, and I'm just hitting the up arrow a couple times to get back. Erase this part and just have my color array here, So it says we have 6 items, 1, 2, 3, 4, 5, 6. Now let's try calling a method or a function on this array. So dot, and you can see a list pop up that will show you what you can do with the array. So let's reverse it. So click reverse, and then see that tells you right there that it's a function. So if you see that little F symbol, it means this is a function. And remember from last time, anytime you type a function, you have to put parentheses. So type open parenthesis and then close parenthesis. And that will call the reverse function. So let's try that. And look at that. Now it's backwards. It's violet, blue, green, yellow, orange, red. And we can do that on the number array too. So let's try that. My number array. And as you recall, that's 1 to 10. So now I want it to be 10 to 1. So let's try that. Dot reverse. Click there. And then it's telling you, oh, it's a function. Now, if you forgot the parentheses for some reason and you just hit enter, it's just going to give you the code, and it says native code here, so it doesn't really do anything. You have to use the parentheses in order to call a function and in order for it to do something. So let's add the parentheses now, and it should work. Great, so we got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's reversed. And you can do that as many times as you like. I can do it again, and it'll put it back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since arrays are considered objects in JavaScript, you can call methods or functions on that array. So I think that's pretty cool. Let's clear the console. And now let's go over another data type in JavaScript called a Boolean. And a Boolean type can only have 2 values, either true or false. So let's type an expression into the console. So 5 is less than 6. And you can see it comes back with true. So that is a Boolean value. It's not a number, it's just a value of true or false. Now let's do the opposite. 5 is greater than 6. And that is not true, of course, so it comes back false. Just as we put mathematical expressions into variables, we can also put these Boolean values back into the variable that we declare. So let's create a new variable and then put the result of a true or false decision back into it. So let, and then I'll call this is less than. Equals 5 is less than 6. And then remember the semicolon. Now hit enter. And then we need to retrieve that value. So type is less than. And then hit enter. And it comes back true. 5 is less than 6. And then you could do likewise, let's try is greater than equals 10 is greater than 11. And hopefully you know what the answer to that is. And so let's type is greater than to see the value. Yes, it's false because 10 is definitely not greater than 11. Now remember our type of keywords, so type of, and you can find out the type of any variable that you want. So is greater than, and there it shows that it is definitely a Boolean value. And remember, Boolean can only have true or false. So let's clear the console. Now I'd like to go over some comparison operators in JavaScript. And these comparison operators should be familiar to you. There are things like greater than, greater than or equal to, less than or equal to. The one notable exception is equal to. And so we'll cover that in a moment. So let's just do the basic ones now. So 7 is greater than 6. Yes, true. 7 is less than 9. True. Seven is greater than or equal to 7. True, because 7 is equals 7. 7 is less than or equal to 10. Yes. Now to check for equality, you might think, oh, 7 equals 7. But in the JavaScript programming language and other programming languages as well, this operator, the equal sign, is called the assignment operator. And that's what you use to assign a variable a value. And so to check for equality, you have to type another equal sign. So 7 is equal. So you can read this as is equal to 7. And now you get the value you expected, which is the Boolean value of true. We can test it out again. 7 is equal to 8. And that's, of course, false. So if you're kind of new to programming, this can be a little tricky, and it can be the source of many hard-to-spot errors. So just try to get in the practice of doing a double equals like that to check for equality. In more recent versions of the JavaScript programming language, we can have an even more strict equality. So we can actually have 3 equal signs, and what that does is it ensures that one of them doesn't get changed at the last minute so that it can make the comparison. So for instance, let's try 7 is equal to 7 string. Now you might think, well, yeah, the number 7 is equal to the character 7, but in certain situations, that might give you a surprising result that you didn't expect. That might lead to some hard to spot errors in your code. So what you want in that case is a triple equal sign. So 1, 2, 3 equals, and now try that again, 7. And it comes back false because the number 7 is different from the string or the character of 7. That's called strict equality checking. And now let's just quickly go over the not equals. So how you do that in JavaScript is 7. I'm just going with the number 7 today for some reason. 7 is not equal, and the not symbol is the exclamation mark. So you put the exclamation mark and then the equal sign. 7 is not equal to 6. Yes, that's right, true. Let's try this. 7 is not equal to 7? Well, that's a false statement. 7 is equal to 7. And then once again, if you use just the one equal sign, it comes back false. 7 is not equal to 7. It's saying that that's false. 7 is equal to 7. So I know it's getting a little confusing, but you can use the strict equality check. So not equal to, then double equal sign. So 3 operators total, and then 7. And now you get the expected result. yes, 7 is not equal to 7 exactly, because the number 7 and the character 7 are different so far as the computer is concerned. Let's clear the console and just take a look at some logical operators. So logical operators are useful when you have multiple conditions that you want to check. And so let's try this. 5 is greater than 3 and 5 is greater than 6. So notice that I put the ampersand twice here, and that's the AND logical operator. So it checks first if this expression is true, and that one is true, but then it also says, well, and this one has to be true as well in order for this whole thing to be true. And so 5 is not greater than 6, and therefore one of them failed, and so it comes back with false. It can only give you one answer, true or false, for the whole thing. So if this whole thing doesn't work out, then it comes back with false. Now let's do one where it's going to be true. So 5 greater than 3, and, so double ampersand, 5 is greater than 2. And that comes back as true. And now there's also another one called the logical OR operator, and that one says if either or are true, then the whole thing is true. So you can think of this as a less strict requirement for truth. So 6 is greater than 5, or, and the way you do that in JavaScript is the double pipe symbol. So that is over way on the right side of the keyboard, and you have to hit Shift first. So press Shift and then do the pipe symbol. And it should be 2 vertical pipes here. And then 6 is greater than 10. So now, even though this expression is false, since this one is true, then the whole thing comes back true. And by the way, this is called short-circuiting the condition, because if it gets to anything that's true, it skips the rest of this and then just comes back with true. So if it finds out that the first or any of the statements is true, it'll just skip all the remaining ones and then come back with a true value. Let's do another one. So 7 is greater than 8, which would be false, but I'm putting less of a constraint on it, so or 7 is greater than 6. So now it had to check both of them. It couldn't short circuit out of it quickly because it had to check first this one, and this one's false. So then it goes on to the next one, and then that one is true, so then it can come back as true. Now, if none of them are true, it'll come back false. So let's try that. 7 is greater than 8, or 7 is greater than 9. Now this time, nothing worked out. So 7 is not greater than 8, so that's false. And it goes on to the next one. Well, let me try this. 7 is greater than 9. Nope. So I have to come back with false. None of those things were true. And so we can chain together these ORs and ANDs and make quite complex conditional statements or checks in our code. And so I only string together about 2 or 3 of these at most, because it kind of gets confusing after a while. If you have a bunch of ANDs and ORs and stuff, it's hard to follow sometimes. But it's a very useful thing because you can do a short circuit or like a quick check of truth or falseness. Okay, now let's take a look at some conditional statements in JavaScript, otherwise known as if and if-else statements. So the way that we do branching in JavaScript is that we type the keyword if, and then open parenthesis. And now you can put any condition that you want inside the parentheses. It can be a mathematical expression or a variable or anything that evaluates to true or false. So let me start out with a mathematical expression. So if 5 is less than 6, and then hit enter. And on the next line, type the left curly brace. So, and that's the ones that's over the square bracket. So shift square bracket and you should get the curly brace. Now it gives you an opening curly brace, and then hit enter. Now let's print something to the console. And how you do that in JavaScript is to just type console.log, and then you put parentheses, and whatever you want to print to the console, you put it inside the parentheses. So let's try that now. Console.log, opening parenthesis, and then let's do a string. So quotes, 5 is less than 6. Hit enter, and then now close up the curly braces pair. So right curly brace. And now you should have a conditional statement here with the if keyword and then a condition to test. And if that evaluates to true, it will execute whatever code is inside these curly braces. And this is called a block of code. So it'll execute whatever is inside of this block of code. So now hit enter after the last curly brace. And yes, it printed out to the console, 5 is less than 6. So the JavaScript interpreter reads the if, and then it goes, okay, there's a condition coming up, so I need to check that. Is 5 less than 6? Yes, it's true. So therefore, I'm going to do whatever is inside the matching block for this if statement. And that tells me to console log this message, 5 is less than 6. And that's indeed what we see. So now let's try one where it doesn't evaluate to true, but rather evaluates to false. And you'll see that it skips over the block. So to get back the code that we just entered, just hit the up arrow key and then change the less than sign to a greater than sign. Now let's hit enter one more time. So nothing happened now because it gets to here and checks the condition. Is 5 greater than 6? Nope. So it skips over all this and then continues the execution of the program, whatever's below that code block. So we can use multiple if statements like this to branch off our code into different paths. And I have a nice illustration of how I think about it here. So this is an aerial photo of a river delta. Let's zoom in a little bit. So for this analogy, pretend that your code is like water and it's just flowing. And so it's flowing all the way from here where my mouse pointer is, all the way down to the ocean. But on its way, it has some decisions to make about which way to go. And so as it's flowing here, it gets to this point, and it's appropriate that my cursor turned into a stop or a grab symbol. It looks like kind of like a stop symbol. So it says, wait a minute, you have a decision to make. Is 5 less than 6? Yes. So if 5 is less than 6, then I want you to go down this path and execute all the code that's down here. If I have a false statement like is 6 less than 5? No. Then I want you to go down this path and execute this code. So let's say that you had the true condition first, so 5 is less than 6. So it goes down this path, and that's kind of like putting a dam on this part of the river here, or putting a bunch of debris or logs here so the water doesn't flow down there anymore. So it goes down this branch. Now it gets to another if statement, and it says, hold on, if something else is true, then I want you to go down this way and execute that code. If not, I want you to go down this way. But you can have multiple of these if statements all chained together. So you can say, if this one's true, go down this path. Else, if this is true, go down this path. Else, if none of those are true, then just default to this path. So you can see how you can chain together these if-else statements and get your code to branch off into different directions in order to handle different situations. And so that's really useful in programming, is to have some kind of conditional logic and branching in your code. And so wrapping up the analogy, the code flow, the program flow, keeps going this way, and it eventually is going to reach the bottom. It's going to reach the end of your code. But the path that it takes to get there can be different based on your if statements and your branching in your code. Let's do one more example with a conditional flow. So let's clear the console and let's make an age check program. So let's create a variable called myAge. So let myAge equals, let's say 30. Now let's do an if statement to check a condition. So if, now we're going to test my age. So my age is greater than 16. I'm going to check if the person entering the age is old enough to drive. Here in the state of Texas, you have to be 16 or older. So if my age is greater than 16, then do this following code. So we type, remember we type the left curly brace, enter, and then let's console log something out to the console. So console.log, and then we just give it whatever message we want to. So congratulations, you are old enough to drive. And then remember the closing quotation marks, and then closing parenthesis, and then the semicolon. And now we close up the curly brace pair. That gives us a pair of curly braces and defines the block for this if statement. So if this evaluates to true, it's going to print this message. So it printed out, congratulations, you are old enough to drive. So first it got to this if statement and goes, okay, I have to check some kind of condition. So here it is, my age. The interpreter goes and looks that up, and that's 30. So is 30 greater than 16? Yes, that's true. So therefore, it's going to do whatever is inside these curly braces. So it does console log, congratulations, you are old enough to drive. Now, what if we had an age that was too low? So my age equals 15. Okay. And then let's try that if statement again. So go up arrow, do the up arrow twice, and then hit enter. Well, it's correct that it didn't print out congratulations, you are old enough to drive. It should not have done that, right? Because 15 is not greater than 16. But it didn't print out any other information, and so therefore your user is going to be like, well, what happened? Why didn't it say anything? So let's make it a little more friendly and display a message if the age is too low. So let's clear the console to get back up to the top and hit the up arrow. And now if you want to put multiple code lines in your console without actually running the code, because if I hit enter right now to get on to the next line, it's just going to execute this. But what I really wanted to do is, see up arrow, I wanted to go down here and add some more code. So how you do that is shift enter instead of just enter. So shift enter will put you on the next line, and it won't execute the code yet. It'll let you put in some more code, and then when you're ready to execute the whole thing, the whole program, you type just the enter key. Now let's make a clause for if the age is below the limit. So else, and this is another keyword, so if this doesn't happen, this will happen here. So if my age is greater than 16, else do this. So now hit enter, and you can hit enter now because it knows that you need to fill in a code block for the else condition. So in a similar manner, we put left curly brace, enter, and then let's print out a helpful message so the user knows what happened. Console.log quotes, sorry, you are not old enough to drive. And then put quotes and then closing parentheses and semicolon. And then now finish it up with a right curly brace. Okay. So now our program worked because if you recall, my age was 15, I believe I set it to. And so it checked here first. It says, is 15 greater than 16? No, they're not old enough yet. So it goes to the else block. Then it executes whatever is in the else block of code. And then therefore it prints out, sorry, you are not old enough to drive. We can do one more refinement to this, and the driving age is 16, so you can actually be 16 exactly and you're able to get a license. So let's fix this by, let's see, clearing the console and hitting up arrow to get our program back in its entirety. And now just change this to a greater than or equal. So greater than or equal. And then it's still, sorry, you are not old enough to drive because it's still 15 as my age. So let's change my age now, my age. If we could only do this in real life, right? Change my age to 16. Now I'm 16 years old exactly. Can I drive? Can I get a license? So now go back, hit up arrow a couple of times to get back to the if else statements and hit enter. Congratulations, you are old enough to drive because you're 16 years old. Let's clear the console and add one last thing to this little tiny program. So hit the up arrow to get the program back. Now it would be helpful if this message said how old your age is and that it verified what you typed into it. So let's add congratulations since you are, and then we're going to do the string concatenation method that I showed you a little while back where we stick two strings together. But in the middle of those strings, we're going to put a value. So congratulations since you are, and then hit the quotation marks. Now that kind of messed this up, but we're going to fix it in a second. Now do the plus sign. And let's print out my age in the console. So call the variable my age, space, plus, and then do a quote. And it's going to print this number right before the Y. So let's give it a comma and a space. And then let's do the same thing here. Sorry, since you are, quote, and then space, the plus symbol, space, put a quotation here. And then again, we do my age plus. So reading from left to right as the computer would, it's going to print out congratulations, since you are space, then it sticks whatever my age is right there. Then it puts a comma, space, you are old enough to drive. And then likewise, in this statement, sorry, since you are space, and then it puts whatever the age is. And then we have to do something similar here that we did here. So, comma, space, you are not old enough to drive. And so it's going to stick all that together into one big sentence or one big string. So now let's hit enter. And I believe my age is 16 still. So let's see if that works. All right. Congratulations, since you were 16, you were old enough to drive. And so see how it just put the variable my age right there, and it turned it into a string to do that. So it's pretty cool. It just mashes everything together into one big string. Now let's change my age again. So my age, I'm going backwards now. So my age equals 3. I'm just a toddler. Okay. And then let's hit the up arrow a couple times and then hit enter when your program comes back. Whoop, sorry, since you are 3 years old, you are not old enough to drive. Well, I would hope so. So you can see the power of string concatenation, which is a fancy word for splicing strings together. And you can also add in variables in the midst of all that and mix around strings and variables all in the same output. And so you can see the usefulness of this when you're trying to log out a message to the user or log out some debug information for your own sake. You can mix and match all these strings and variables, and it'll just mash them all together and then put them all into a big string as an output. So that's really useful. Let's clear the console. Let's take a look at a couple of more operators that you can use with JavaScript. And those are called the increment and decrement operators. So we'll take a look at the increment operator first. So let's say I have a variable called I, and we'll set it to 0. If I type I++, that will increment the variable I by 1, which is essentially just adding 1 to whatever you have inside of I. So, and it is a statement, so let's remember the semicolon. Hit enter. Now it's a little confusing because you think that I didn't get changed, but actually I is now 1. What I think is going on is the interpreter gets to the I and then evaluates that right away, and then it just puts that back out in the console. But it actually does do the increment. So it adds 1 to whatever I was. So now if you type I again and evaluate I, enter, then you should get back 1. So now I is 1. If we do it again, I++, semicolon. Again, it's a little confusing because it gives you back what I was just a minute ago, but now I is indeed 2. So let's check that. So type I, and to get out of this little pop-up menu, you just hit escape, by the way, and then enter. And now I is indeed 2. So it's just kind of a shortcut way of adding 1 to a variable. And likewise, you can do the same for subtracting 1 from a variable. So let's try that. So I is currently 2, and the decrement operator is minus minus. So I minus minus. Now again, it gives you, the interpreter evaluates I at that moment, and then it does the operation. So it gives you back 2, but if we check I now, it should be, let's clear the console. And if we check I, hit escape, and then enter, it should be back to 1. So 2 minus 1 is 1. And then you can do it again to get back to 0. So I minus minus, semicolon. And again, it gives you back 1, but it really did change it. So type I in the console again, just to check on it, and it is indeed 0. Usually you will find these increment and decrement operators inside of a loop. And so we'll get to that shortly. So now let's go over how you do loops in JavaScript. And loops in JavaScript are very much like the C programming language. And a lot of the syntax that you'll see in JavaScript is borrowed from the C programming language. So probably the most widely used loop is called the for loop. And you type for, and you can see some options pop up right away. For now, let's click on the for loop option right here. So now it populates the code necessary to do a for loop. And so we'll talk about each of these sections of the loop now. So you start off with the keyword for, then opening parenthesis and closing parenthesis. And inside those parentheses, we initialize a variable. And so that can be any name that you like. Usually it's I or index. So this is the initialization part of the loop. So we create a variable and we set it to a certain number. Usually it's 0 because we're looping over an array. And you recall that arrays start with 0 indexes. Then we have the conditional part of the for loop, and that just checks a condition in order to continue the looping. And then finally, we have an update part of the loop, which updates the variable that we had initialized over here. So here's where we see the increment operator in action. So it takes whatever index is. So in this case, it would be 0 on the first time through the loop, and then it adds 1 to it. So index plus plus, now index would be 1. Then it goes through the loop, and if it does this again, the 1 will turn into a 2, and then the 2 will turn into a 3, and so on and so on. Now, in order for it to do anything in this body of the for loop, this condition must come back true. So if this is false for any reason, it'll immediately stop the loop. And just stylistic preference, I like my curly braces to be on the new line by themselves. So I'm going to hit Shift Enter to put that on a new line. I just like the look of this a little better. You can have the opening curly brace on the same line as the for loop, or you can have it on its own line, and I just prefer it to be on its own line. Let's give it a condition first. So index is going to be 0, and then we need to fill in the bound. This is the limit. So let's do 10. So now it'll do whatever is inside this body basically 10 times. So index starts off at 0. Is index less than 10? Yes, 0 is less than 10. And so it does whatever you have in the body of the loop. Then it updates the variable. So it adds 1 to index. Now index is 1. So it goes back and rechecks this condition. Is 1 less than 10? Yes. So it does the loop action. Then it updates the variable. So now 1 plus 1 is 2. And so is 2 less than 10? Yes. So it does the whatever is in the body of the loop again, and so on and so on. And so it'll go all the way until index reaches the number 10. And then when it gets to the condition, it checks, is 10 less than 10? No. So then it immediately stops, and then the program execution continues below the for loop. Whatever code you have down here below the for loop will be executed then. So let's give it something to do for 10 times. Let's print out to the console the index number itself. So how we do that is console.log, and then you just put the variable in there, so index semicolon, because it's a statement. And now when you hit enter, it should print the value of index as it goes through the loop. Great, so index was 0, so it printed out that. Then the check passed, so it printed out 1. The check passed again, it passed again, all the way down here. 9 is less than 10, that passed, so that printed. But then it got to the number 10, and 10 is not less than 10, so it stopped. It says, no, that's false. So it exited out to here, and then it goes below that, and we didn't have any more code below the for loop, so it just terminated at that point. So looping in any language is very important, and it saves a lot of space, and it allows you to iterate over large groups of data like arrays. And that's what we're going to use it for in our graphics programming. We'll essentially loop over all the pixels on the screen. And so you can have a million pixels on your screen. So we're going to do this little loop here basically for 1,000,000 times. But the computer does this very fast and very efficiently. And it's no different for JavaScript. The JavaScript engine in your browser has highly optimized code for loops like this. So we'll be able to take advantage of that. Let's clear the console and take a look at another kind of loop that is widely used, and that is the while loop. Let's first create a variable called j, and we'll set it to 0. And now you type the keyword while to create a while loop. And we put a condition inside the parentheses. So j is less than 10. And then closing parenthesis. And now opening curly brace. Now you have to be careful with while loops, because if you don't update the variable on your own, then it'll just keep passing this test, and whatever you have in the body will go on forever. It leads to what is called an infinite loop. So let's print out the value of j. So console.log parentheses j parentheses and then semicolon. And now we make sure we update j on each iteration. So eventually it'll fail the check at the top of the loop and it'll exit the loop. So j++. And that will add 1 to j on each iteration of this while loop. And then semicolon, because it's a statement. And now closing curly brace. And then when you hit enter, it should print out the value of j, and the numbers should be again a 0 through 9. So let's see if that happens. All right, cool. So again, it printed out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so the test passed while j was less than 10. But as soon as it got to 10 itself, then 10 is not less than 10. And it fails this check. And it exits the loop and then just continues the code execution down here below the while loop. So between the two loop styles, the for loop and the while loop, I prefer the for loop because it has those checks built into it when you declare it. And so there's less chance that you're going to get an infinite loop with a for loop than you do when you use a while loop. So we'll be using primarily for loops for the time being, but then maybe in the later part of this series, when we get into shader programming and walking a tree structure in the shader, we might use a while loop at that point. All right, so let's clear the console, and now let's talk about the object in JavaScript. And this is arguably one of the most important constructs in the JavaScript programming language. A lot of things that you work with in JavaScript are objects. And so what is an object? Well, how I think of it is an object is kind of like a record or a database. And so if you imagine making a record of something or keeping track of something, you would give it properties and values for those properties. So if I had a record of a car, I would say, okay, what kind of car is it? Maybe what color is it? What year was it made? And what's the model? Things like that. And the object in JavaScript encloses all that data or all that record keeping under one variable name. So let's practice creating some objects now. And how we do that in JavaScript is type let. How about we make a person object? So person object. And again, I'm using camelCase, so the second word is capitalized. Equals. And we type the opening curly brace and the closing curly brace. And that creates an empty object. So opening curly brace and closing curly brace. And then end the line with a semicolon. And so now we have created an empty object. So this pair of curly braces is empty. There's nothing inside. So right now this doesn't have any data, but we're about to add some to it. If we go back to the record analogy or keeping a database of something, we will typically give it properties and then values for those properties. So let's add some properties to this person. And when you think of keeping track of a person, then certain things come to mind. So let's give the person a name property. Person object. And how you give it properties is you type the dot operator. So dot. And now we can just define a new property. So name equals. And text or strings of characters should be strings in JavaScript. So let's create a string for the name. So quotes, and I'll just do my own name, quotes again, and then semicolon. Okay. So now let's check the type of this variable. So, and if you recall how to do that in JavaScript, it's type of person object. And yes, it is indeed an object in JavaScript's eyes. And we can also check the type of the name property, type of person dot name. And yes, that is indeed a string because it has quotations around it. It's a string of text. So let's add some more properties to this object. So person object. Let's create an age. So age property equals, and then this one's going to be a number. So put my own age here, 49. Okay, and we can check the type of that property. Type of person object dot age, and that should give back the number type. So that is indeed what we wanted. Good. And now let's add one more thing to this object. So person object. Let's give this person a list of hobbies. So hobbies equals. Now, if you recall, the way we do a list of something is create an array in JavaScript, and that is the square brackets. And so we do the left square bracket, and then a list of things separated by commas, and then a right square bracket. So left square bracket, and I'm going to put my own hobbies here. So graphics, programming, and then remember the closing quotation marks. Now you separate the items in the list with a comma. So comma, space, and then the next hobby, so game programming, comma. And I actually love billiards, so I play American pool like 8-ball and 9-ball, and I also play the European style, which is 3-cushion billiards. So I'll just put billiards, which encompasses all those games. Then remember the right square bracket and then the semicolon. Okay, so that gave back out in the console all of the hobbies that I had listed. And as you can see, you can have any type of data that you want associated with the object. So you can have a string, such as the name. You can have a number, such as the age property. And then you can have a whole array inside of the hobbies variable. So the object itself in JavaScript is very flexible. You can consider it as like a collection of data that doesn't have to be of the same type. So you can put like numbers, strings, arrays, whole other objects, so whatever you want inside the object itself. Now let's clear the console and let's get some practice writing out some strings to the console and accessing some of these properties that we had created on the person object. So let's try console.log person object.name. And then it gives back Eric. So that is indeed what we had put in the name property. Now let's have some fun by creating a string that's an entire phrase that uses all of the properties of the object that we had just created. So and I'm going to create a string called greeting. So greeting equals, and this is a string, remember, so quotes, hi, my name is space, then close the quotations. And now let's access one of the properties that we had set on the object. So plus, and we want the name property. So we do that by accessing the person object and dot operator, and then the name property. Let's just see what the console gives back on this statement. So now, in order to evaluate that, we type greeting and hit enter. And there we go. Hi, my name is Eric. So it just filled in the person object name right here and then stuck it on the end of this string here. And that, remember, is called string concatenation, which is a fancy word just for mashing strings together. So let's take this a little further and give all the information that we have about this person. So let full greeting equals hi, my name is space person object dot name. Now let's continue with it. So plus quotes, and remember a space because when this gets done sticking the name Eric in there, it's going to start right after that age, so we need a space. So push space right there, and now we can print some more text. So hi, my name is name, and I am space. Now close the quotations for this phrase here, and then plus, and now we're going to access the person object's age. So person object's age. And then remember the space when you start typing out the text again. So space years old, period. I have, what I want to say is how many hobbies do I have? So if you recall, on an array, you can find out the amount of items in an array by accessing its length property. So let's do quotes plus person object dot hobbies dot length, and then it pops up here. That will give the number of hobbies that I listed, which should be 3. So then we can continue plus. So let's add a comma here, and then we'll do one more thing. So, but my favorite hobby is, and now usually when people list their hobbies, their favorite one is the first one. So how do we get the first hobby out of my list of hobbies? And if you recall from our discussion about arrays, it starts with an index of 0. So we want hobbies 0. So first we access the person object, then we look up the hobbies array, and then we access the first element in that array by typing a left square bracket and then the 0 index, which is the very first index. It has an offset of 0, so it's at the very beginning of the array, and then right square bracket. And then just to be complete, let's add a period. So period, quotations, and then finally a semicolon. So this is quite long, so let's make sure that we did everything correctly. Hi, my name is blank, and then we fill in the blank, and I am blank years old. I have blank, this is kind of like Mad Libs. I have some number of, oh, we forgot hobbies. So we need a space here and then hobbies. Okay. I have some number of hobbies, but my favorite hobby is, and then whatever that is. Oh, and we forgot a plus here. It gets kind of complicated when you have a lot of different string literals and then object properties and values, and they're mixed in. But I think we did everything correctly. So all these person object properties should be surrounded by pluses. So you can do a quick check on your code that way. So this has a plus on the left and the right, plus on the left and the right, plus on the left and the right, and plus on the left and the right. So I think we should be good to go. So let's try this now. So hit enter and then type full greeting to print it out in the console. Okay, hi, my name is Eric and I am 49 years old. I have 3 hobbies, but my favorite hobby is graphics programming. So true. So you can see the power of the JavaScript object, which allows you basically to put any kind of data all under one umbrella, so to speak. The fact that you can have different types of data under the same name is very useful. And so we will be using that down the line. Let's clear the console. And lastly, I would like to go over functions in JavaScript. And just like the object, the function in JavaScript is very important and arguably the most important. Functions in JavaScript are first-class citizens. And so if we use an airplane analogy, when you think of first class, what do you think of? Well, the people who are in first class get all the perks and they can move freely about the cabin. They can go wherever they like. And in JavaScript, the function is truly first class. It can go wherever you want. You can use it as a parameter to a function. You can create a function within a function. You can give properties to a function. So it can go anywhere. It can move freely about the cabin, and it gets all the perks of flying first class. So let's create a simple function first just to see how it works in JavaScript. And typically when I create a function in JavaScript, I prefer the function definition method. So that just involves typing the keyword function. And we want to give our function a name. So let's make an adding function. So it'll add 2 numbers together. So add numbers. And then now, since it is a function, functions require the parentheses. So you do opening parentheses, and this will take 0 or more arguments, or as I like to call them, parameters, for the function to be able to do something useful. Let's define it as taking 2 numbers and then adding those 2 numbers together and then giving you back the result, which is the sum of those 2 numbers. So we'll call this first parameter number 1, comma, and the second one number 2. Now in defining functions like this, you need to put the opening and closing curly braces. So let's do that. Hit enter and then type left curly brace. Go on the next line, and we'll close up that in a minute. So inside the function body is where we actually do the work of the function. So let's create a temporary variable inside this function. So let result equals, And then we're just going to add the first number and the second number together and then put the result back into the result variable. So num1 plus num2, semicolon. And most functions will return some sort of value. They don't have to in JavaScript. You can have a function that you call that does some sort of action off to the side, and then it comes back to the main execution of the program, which is kind of like a subroutine in other languages. But let's go ahead and make a return value for this function. So return keyword result. And it's a statement, so semicolon. And now let's close up the curly brace pair. So you should have a left curly brace and a right curly brace, and then the body of the function is here. So just to go over this one more time, we declared a function called addNumbers, and it takes as its parameters a number and another number. So we named this one num1 and num2. Then it goes inside the body, and we created a temporary variable called result. So let result equals num1 plus num2. So it'll add the numbers, and then on the next line it returns whatever that result is. Let's try that out now. So hit enter, and in JavaScript, when you want to use a function, you call that function by using its name and parentheses, and any parameters that it might take go inside those parentheses. So add numbers, and you can see right away that it gave a little F symbol here, which is the function. And so if we hit enter at this point, it's just going to give us back what we define the function as. So far as JavaScript knows, addNumbers is a function that takes two parameters and then does this code, and that's it. But to actually call it, we need to use the parentheses. So addNumbers, now type opening parenthesis, and then it gives you a helpful reminder as to what you define this function as taking. So it says it needs a first number and a second number. Let's do 5, 3. And then closing parentheses. And it already evaluated it, so it is indeed 8. But let's hit enter. And actually it's a statement, so semicolon and then enter. Then we get the value 8 back. So 5 plus 3 is indeed 8. So it took whatever you gave it for this parameter right here, and then it took whatever you gave as this parameter and put it right there, and then added those two numbers together, stored it in the variable called result, and then returned that result. And you can also use functions in combination with variable declarations. So let's try let sum equals, and then we just call the addNumbers function, which takes two numbers. So addNumbers, parenthesis, and then let's try 4 and 3, semicolon. So now it performs the addNumbers function that we had defined, adds these two numbers together, and puts the result back into this variable called sum. So now if we type sum, we should get back the number 7, and indeed we do. So functions wear many different hats in JavaScript, so you can call the function like this on its own line, or you can put the result of that function into another variable. Let's clear the console. And so functions are very useful in JavaScript, and one of their main purposes is to construct objects. and so they become what is known as constructor functions. Let's say we had a number of objects that we needed to make and keep track of. So if we had a bunch of cars to catalog, let's say, we could create a constructor function called car. So let's try that now. Function. And now typically when you name a constructor function, it starts with a capital letter. So let's do capital C-A-R, function car. And it's a function, remember, so it takes parentheses. So opening parenthesis. And now we can give it some parameters that we want it to start out with. So how about make model year, and then hit enter, and then the opening curly brace, hit enter to go on to the next line. And for constructor functions like this, we use the keyword this, and the this keyword refers to the object itself that you're about to create, and we put properties on that object, just like we did moments ago with the person object. So type the keyword this dot, and then let's create a property on this object, because this function is creating an object. So what do we want this object to have? So let's have a make. And let's take whatever parameter was passed into the function. So you just type make again, and then type semicolon. So what this does is whatever the user passes in as make will be put into the property of the same name. So this dot make will be whatever they put in as the make parameter. To someone coming from another language, this might be a little confusing right now, but the more we do it, the more you'll kind of get used to it. So let's try some more uses of the this keyword. So this dot, and then we're just going to go right down this list here. So model, let's give it a property. So now this object will have a model property, and let's set it to whatever the user called it with in the function parameters. So model, and then let's do another one for year. So this dot year equals whatever they passed in for the year parameter. And then now remember the closing curly brace. Okay, so if you take a look at this constructor function, we have the keyword function, then the name that we picked, and it starts with a capital letter. Then it takes some parameters. This can be 0 or more parameters. You don't have to have anything as taking parameters, but I just decided 3 for this particular function. So it's going to take a make, a model, and a year. And then whatever object that we create with this function is going to be this. So you can put the object in place of this. And then now it has properties. So remember how we access properties in JavaScript, we do the dot operator. So dot, and then we can name this whatever we like. So I just kept the names the same as the parameters. So this dot make equals whatever it was passed in as make. This dot model is model. This dot year is year. And so now our newly created car object will have properties of make, model, and year. And you can create as many of these as you like. That's the cool thing about constructor functions and the power of functions in JavaScript. So now let's try this out. So let's see, my car equals, and to create a new instance of this object, we use the new keyword. So new car. And now remember, car is technically a function, so it takes parameters, and therefore we have to put the opening parentheses, and now it reminds you what you had defined it as, which is helpful. So it takes a make, model, and year. Now, make and model will be strings with quotations around them, but year should be a number. So let's type forward, comma, and now we're on the model parameter. So focus, comma, and 2014. And then close the parentheses. And now this is a statement creating a new car object. So it says let my car equals new car with these parameters, and that's a statement, so we end it with this semicolon. Okay, so now let's see if this constructor works. So we're going to call my car and then hit enter. All right, cool. It looks like it works. And you can expand this arrow here by clicking on it. And then in D we get the make, model, and year. So make is forward, model is focus, and then year is a number, which is 2014. And if you do type of my car, it is indeed an object. So we have successfully created an object. Now the cool thing is you can create as many of these as you like. So let's clear the console. And so we'll leave the world of functions for now, but just know that functions are first-class citizens in JavaScript. And so they wear many hats and they can do many different types of things in JavaScript. And you can even pass them around as parameters to other functions, or use them as objects, or create functions inside functions, and have callback functions, respond to users' events in the web page. So there's all kinds of things that you can do with functions, and they're really powerful in JavaScript. So the final thing I like to talk about in JavaScript is the concept of inheritance. And inheritance comes into play when you want to create a bunch of objects that have the same type of properties and the same type of methods. And so they inherit those properties and methods or functions from their parent class. Now, when JavaScript was first created back in 1995, it didn't really have the notion of classes, but it does offer the technique of inheritance by way of prototypes. And so we'll take a look at that now and how you do that in JavaScript. So now that we've created the car constructor function, and let's recall what that looks like. Car, and you can see here it's a function. And if I hit enter, it'll give us back what code we typed for the car function itself. Now let's say I wanted all my car objects to be able to perform an action, like rev up the engine or honk the horn or something like that. So how we add methods to this car constructor function in JavaScript is by typing car dot, and then you'll see prototype pop up here in the list of options. Click on that. And so in JavaScript, each object has a prototype. And if you think about what a prototype is, it's kind of like a proof of concept or the beginning of something or a first iteration of something. So when you add to the prototype of this object, you're just defining what you want it to be able to do. So it doesn't actually perform the action, but you're just defining what it's able to do. The prototype is an object itself, so we have to type the dot again. And then let's create a name for our function that we want all cars to be able to do. So how about startup? And then type space equals space. Now here's where functions come into play again. They're so important in JavaScript. So let's type the keyword function. So we're saying that startup is a function, and all functions in JavaScript have to have the parentheses, and they can take 0 or more parameters to the inside the parentheses. So now let's have this one just do an action, but it doesn't take any parameters. So close up the parentheses and hit enter, and now the opening curly brace, and we're going to define the body of the function now. And let's just have it print something out to the console. So console.log vroom. That's the sound of a car starting up. So close the parentheses and then semicolon, because that's a statement. And now close the curly braces. So now we have defined a function called startup that all cars will have once we create them. Okay, let's clear the console and create a new car. So how about let cool car equals, and then to create a new car object from the car constructor function, we use the keyword new. So new, and then it's capital C-A-R, and that's our car constructor function. And then it's a function, so it uses parentheses to take parameters, and then it reminds you of what those parameters are. So let's do, so I'll stick with Ford today. Mustang. Let's make it a brand new car. So, and then close the parentheses. And then it is a statement in JavaScript, so semicolon. Okay, so now if we type cool car, we should get back what we put into it. And so we have the make, Ford, model is Mustang, and year is brand new 2022. Okay, so let's see if this car can perform an action. So I want to start up this car. So cool car, start up. And remember, start up is a function. So even though it doesn't take any parameters, it still needs opening and closing parentheses. So open, close parentheses, and then semicolon, because it's a statement. You're calling it to do an action. So there you go. And so it started up, boom, and we're able to take this car for a spin. So let's add one more method on its prototype. All cars should be able to honk their horn, right? So let's add that to a prototype of a car. You're essentially saying that when you create a new car, that all cars will have this ability. And that's the prototype. So let's add to the prototype of car, so car.prototype. And then prototype is an object itself, so dot. And now it offers us startup here, but let's do honk. We're just going to create one, and then equals, and this is a function, so function. And let's get some practice with loops. So this function will take a number of times to honk the horn. So opening parentheses, number of times. Closing parentheses, and then go on to the next line. and then type the left curly brace. And now we're going to define the body of the function. So this is what it's actually going to do. Now let's practice our for loop. So for, and you can see it pop up right away. So let's click on for loop. And it creates the code necessary to do a loop in JavaScript. And let's leave the index at 0. But now the bound we're going to put as number of times. So just type number of times. And then inside the body of the for loop, we'll say console.log quotes, because this is a string. So let's have it say beep. And then close the quotes, close the parentheses and semicolon. So just to reiterate, the index will start at 0 on this for loop. Then it'll check the condition, is 0 less than the number of times? Well, that depends on the number of times. So let's say I put 5 times. So 0 would be less than 5. So that check passes. And then it goes down and does whatever is in the body of the for loop. And let's make this curly brace on the next line. I just prefer looking at it that way. So enter, and that'll put it on the next line. So it'll perform the action, and then it'll update the index variable. So it'll add 1 to it on each iteration of the loop. So now index will be 1. That's less than 5. It passes again, and then it'll console log beep. And then it'll add 1 and so forth, all the way until it gets to 5. And when it's actually 5, 5 is not less than 5. So that check will fail, and then it'll go past the body of the for loop and then just continue on from there. Now let's remember we have the opening curly brace for this function called honk. So let's remember to close that up as well. So now you have a left curly brace and a right curly brace. The same thing goes for the for loop. You have a left and right curly brace defining the body of the for loop. Okay, so when we hit enter there, it gives us back our code that we had typed in. Let's clear the console now so we can get back up to the top. And let's try out our new honking feature. Let's make a new car object. So let impatient car equals new car. And it's a capital C because that's the constructor function that we had created. And that takes the make, model, and year. So, and I'll just stick with forward again. So forward, escape, and the year is an older car. So 2012. And then closing parentheses, and then semicolon. So impatient car is wanting to get through all the traffic, so it's going to honk a number of times. So let's try that out. So impatient car dot honk, and then remember honk is a function, so opening parentheses. And it reminds you that it takes number of times to honk. So let's do 5 as we discussed before. Closing parentheses, semicolon. All right, let's see if it'll honk 5 times. Yay! So it did. Now, since the output is the same for 5 times, the browser doesn't want to take up the room down here of printing out the same thing over and over again. So it just puts the number of iterations that it did. But it did, in fact, beep 5 times. And so now we've created an impatient driver. So let's make the driver even more impatient. Let's see, impatient car dot honk 20 times. And there it is, 20 beeps. And then if you hit up arrow on the keyboard, you can change this number. So let's do 1. So it's not as impatient now. So we get 1 beep. So this was just a little demonstration of how you can have inheritance on your objects. Now hopefully you can see how inheritance works in JavaScript. So you take the prototype of that object and then you change it by adding properties or methods or functions onto that prototype, and then all new objects that get created with that constructor will have all those properties and all those functions. That's how inheritance is accomplished in JavaScript. Well, that concludes my whirlwind tour through the land of JavaScript. We barely scratched the surface of what JavaScript can do, but I hope you got a little insight into how JavaScript works and how you can use it as a tool to make different components of your programs. So we're going to leave the browser console behind for now and go back to our web page that we were working on. And I always like to do at least a little bit of graphics programming on every episode. So now let's see if we can use our new knowledge of JavaScript to make our web page more responsive and interactive. So let's do that now. So click out of the console, and here's our style canvas that we were working on last time. And here's the code for the HTML. So since we are going to add some new functionality to this page, let's make a new HTML document and a new JS file to go with that document. So let's click on Style Canvas to make sure you're in the root folder, and then click on New File. And let's name this Interactive Page. .html. Hit enter. So now go back into Style Canvas and select all this code. Control C and just copy it into interactivepage.html. Control V. Let's change the title. Interactive web page. And now in the JS folder, we can create a new JS file as well that will go along with this page. So it won't be the style canvas, it'll be something else. So let's name it something that's close to this. So go in the JS folder, click on JS. You can click on it a couple times just to make sure you're in that folder. And then now hit New File. And let's name this Interactive Page.js. And this will be a JavaScript file. Enter. So now your folder structure should be a CSS folder with a styles.css file, a JS folder with 2 JS files. One is interactive page and the other is style canvas. And then on the outside of all this is our 3 HTML documents that we have been working on. And so just to get back what we had before, go into stylecanvas.js and select all this code. Go up to the top, line 1, and select everything. Control C, and now click in interactivepage.js and Control V. That'll paste everything in there. And now, as we did before, let's get rid of the older files so we don't accidentally start typing code into them by mistake. So let's click X on the style canvas and X on stylecanvas.html. So now we're only working with these 3 files, and we're actually not going to change this one, but we can just keep it there, the styles.css. We won't do anything with that. All we're going to be working in today is with this interactive page.js. And now let's go into the HTML real quick and update this file path, because now it needs to find this file, interactive page.js. So click to the left of this quotation mark and backspace until you get to JS. And now one of my favorite features about VS Code is it's going to give us some suggestions. So type / and don't you just love it? It gives you all your files there. So let's pick interactive page, and it fills it in. Great. Now currently we have our live server running. You can see by the port number over here, 5500, but it was on the style canvas demo currently. So we have to get back out to the main file menu and then select interactive page.html. So there's 2 ways we could do that. We could either close down the server and then just start it up again, and it would just start up with this one. But I actually wanted to show you a little bit about the live server plugin itself. So go back into your web browser, and you should see Style Canvas still displaying in the browser. Now you'll notice that it has a local address of 127.0.0.1 and then colon, and then this is the port number, so 5500, and that should match what you have down here on VS Code, so 5500. But it's currently on the stylecanvas.html webpage. So what we want is the interactive page.html instead. So click inside the address window and erase the text all the way until 5500 and then hit enter. And now it's kind of cool. You can see your folder structure as if it was on a server. So it has our CSS styles, and it has the JS with our 2 JS files, and it has our demos. So if we click on Style Canvas again, it'll give us that again, but we can go back now. So back, and then remember our very first web page, so we can click on that demo. That was our first one that had the canvas, and go back. And now let's click on interactive page. So that's the current one that we want to work with right now. So let's click on there. And we should see the same graphics. So it's exactly the same. So everything's working. So now let's go back into our code. And if we make any changes here, it'll immediately update that web page in real time. So that's pretty cool. Now for today, we're not going to do anything more with interactive page.html or styles.css. We're going to be only working in this file here, interactive page.js. So first, we're going to do a little refactoring on this code. And in computer programming, refactoring means just making the code more reusable as well as more readable, but the functionality remains the same. So for instance, take this section right here. So we can ask ourselves, what is the computer doing at this point in the program? Well, all it's doing is drawing all the rectangles. So why don't we refactor this simply into its own little routine called draw? And so that's what we'll do now. It won't change the functionality of our web page, but it'll make it into a reusable component. So we can just call the draw function as many times as we want, instead of copying and pasting this over and over again all throughout our program, wherever we need to draw something to the screen. So let's create a function. And so now you remember how to create a function, right? So keyword function, and let's name it draw. So draw. And at this point, it doesn't need to take any parameters. So let's just do an empty pair of parentheses. So opening parentheses, and it'll close it for you. Now go on the next line, enter. And we need to define what the function does inside curly braces. So left curly brace, and it'll close the right one for you. Now you can hit enter. So what do we want our draw function to actually do? Well, we want it to do all this. So let's just take all this, select all that code, Control X to cut it, place your cursor in there, and Control V. And Visual Studio Code indents the lines for us, which is nice. So now we have a draw function that contains all the drawing code. There is a problem, however. So if we go back to our web page, all of our rectangles are gone. That's because we're not actually calling the draw function. So in order to get a function to actually do something, you have to call it. So let's try that now. Click to the right of this right curly brace and hit enter a couple of times. And now to call a function, you just call its name and then use the parentheses. So open parentheses and it closes it for you. Now this is a statement. You're actually doing an action. So semicolon goes at the end of the statement. Okay, now let's see if that worked. So go back to your web page. Yay, okay, all of our rectangles are back. Now let's just take a moment and look over the code with our new JavaScript eyes. So hopefully you should be able to see things that you couldn't see before now that you know how JavaScript works in its basic form. So right away I see the let keyword, so this must be a variable. And then here's the word document, but it has a dot after it. So if you remember when we typed the dot, that was for the object in JavaScript. So this document must be an object. And in fact, where JavaScript shines is its connection to the HTML document, and that is through an API called the DOM API. And DOM is DOM, which stands for Document Object Model. And notice the word object is in the middle. So Document Object Model. And that gives you the ability to change all the elements on your web page and do dynamic things with the elements on the web page through the Document Object Model API. So one of the functions that it has built in is getElementById. And so every document has that ability to get an element by ID. And that takes a string, and we know that's a string because it has quotes around it. Likewise, we see canvas dot. So canvas must be an object, and indeed it is. The canvas object has certain properties and methods or functions available to all canvases. So when you create a new canvas, you can get its width and height properties by using the dot operator again. So canvas.width gets you the width in pixels, and canvas.height gets you the height in pixels. And once you get the drawing context from the canvas, that context is an object itself. So it also has properties and methods or functions that you can call on it. So let's take a look down here at context, and we see it has a fill style property, and that must be a string because this is surrounded by quotes. And so the fill style property is a string. And then if you look down on the next line, context.fillRect, so that is an action or a function, and it takes parameters. So in classical programming language speak, this would be called a method. So the context object has a method called fillRectangle. But I prefer to use the word function because function is so important in JavaScript. And in JavaScript, functions reign supreme. They are first-class citizens. So this is a function on this object. Now we're going to take a look at the DOM API and what that can do for us. And remember, DOM stands for Document Object Model. And so the way you interface with that is through JavaScript. And so the DOM API offers us certain objects and functionality to our web pages. It provides a window object, which is the global browser window object. And so you can tell that it's an object by the fact that it has a dot here, and then its property inner width and property inner height is used. So let's take a quick look at our web page as it is now. And I want to show you something that we can fix with JavaScript now. So let's say a user changes the window size. So if they restore down, now we see the rectangles aren't quite the dimensions that we specified. And so it gets worse if you shrink the window further. Now they're squares, they're not even the rectangles that we had said anymore. Likewise, if you make it wide and then decrease the height of the window, look what happens to the rectangles. They get squashed flat almost. We want our rectangles to be the same dimensions no matter what the size of the window is, because again, you don't know what type of system your end user is going to have. They might be on a laptop or a desktop or a phone in portrait mode and then all of a sudden switch to landscape mode. So we have no way of knowing that in advance. And so we have to build a web page that's more responsive. And how you do that is through JavaScript and adding event listeners. So let's go back in and see if we can fix this now. We can go back into our code. So going back to what we were discussing about the DOM API, or the Document Object Model API, is that it offers us certain objects to work with in our web pages. And one of those is called the window object. And if you recall, the window is the global object for the entire browser window. And so we're going to use that object and use one of its functions that comes built in. We're going to use a function called addEventListener. And so that'll add an event listener to the web page. And when something happens that it's listening for, it'll respond by calling a function. So let's try that now. Click to the right of this line and hit enter a couple times. Now we're going to call the window object and then dot. And as you can see, there's tons of properties and methods on the global window object because it is so big. But what we want for now is a function called addEventListener. So to start typing add, and it should pop up right away. addEventListener, and it indeed is a method, or a function as I like to call it. So click on that. And now since it is a function, it takes parentheses with possible parameters inside. So let's try parentheses and then get this list, which is not too helpful, but basically what we want to do is listen for when the user resizes the window. And so we can just put the resize event in this parameter spot. And that's a string. So quotes and resize. And it should pop up. So we can click there. And now we need one more parameter, comma, in this parameter spot goes the function that you would like to call when the event happens. So when the resize event happens and it detects that on the web page, what do you want to do? So I want to call a function that I'm going to make called, let's say, handle window resize. So handle window resize. Now we haven't created that function yet, so it comes up as any. It doesn't really know what you're talking about yet, but we're about to create that function in the next line. So now this is a function call, which is a statement. So let's end that with a semicolon and go on to the next line. And now we're actually going to define handle window resize and what that does. And recall that this is a function, so we have to use the keyword function. And then just start typing handle window, and it should pop up here because it recognizes that you just typed it a moment ago. And then all functions need parentheses, right? So opening parentheses, and it'll close it for you. For this particular function, we're not going to need any parameters that are passed in. So let's just go on to the next line and define the function. So real quick, going back to the web page, when someone changes the window size like this, they're actually changing the window inner width and the window inner height. So we need to get those new dimensions so we can use those to draw our rectangles correctly. So let's go back into the code now. And you can see here is where we do that. But it's outside of this function. So let's take this and just copy it and paste it in here. So now you can read this code as window, add an event listener, and I want to listen for a resize event. If the user resizes it at all, I want you to call this function, which I define right here. So let's say they resize it. It goes to this and it says, okay, I have to execute this handle window resize. So it goes here and then it performs any actions that you have in here. And so now we get the new window inner width and we place that back into canvas width, and we get the new window inner height and we place that back into canvas height. Now, actually this won't work just yet because we need to redraw the screen. All the dimensions and coordinates are messed up, so we need to refresh the screen and redraw it. And that's why I put all this into its own function, because we can simply just call the draw function now and it'll draw it correctly. Except that there's one thing that I forgot. We need to also update this variable because it's used in the draw function. So we have canvas width, canvas height, and that we're getting a fresh canvas width and a fresh canvas height from the new window dimensions. That's fine. But we also need the half canvas width and the half canvas height, because now those are new as well when the user changes the dimensions of the window. And since we already used the keyword let, those are defined, and we can just use this portion of the code and update them. So select from half to the semicolon and then copy. Then go under this line and then do it likewise for this line. Select half to the semicolon and then go to the end of that line. Click enter and then paste in there. So now we have canvas width equals window inner width, whatever that may be now that the user has changed it. Canvas height equals window inner height, whatever that may be. And then we update half canvas width to be whatever the canvas width is that we got back over here. and then divide that by 2 to get the halfway point. And likewise, we do half canvas height equals whatever we got back from the window. So canvas height divided by 2. And that should update and refresh all of our variables that we need in our draw function. So now all that's left to do is actually draw the screen with our new coordinates and our new dimensions. So let's click here and press enter a couple times and then call the draw function now. And so you remember how to do that, right? So draw, and then it needs the parentheses. And it doesn't have any parameters, so it's just empty parentheses. And then semicolon, because it's a statement. Okay, so now let's see if that worked. So here's our web page with the 5 rectangles and 4 in the corners and then 1 right in the middle. And so no matter what we do with this window, everything should stay the same. So let's see if that's the case. Let's restore down. Looking good so far, much better. Now let's try to squash it flat. Cool. So the rectangles keep their dimensions exactly, even as we mess around with the window as much as we want. And let's try to squash them this way, and they retain their shape. Great. So now our web page is responsive to the user's actions. Let's get just a little more practice adding these event listeners to our window object. And so now what I like to do is when the user clicks on the screen anywhere, I want this text to change. And so I'm going to show you how to do that now. First, we'll need to get a reference to this paragraph element. So remember, we did this with the paragraph or the p tag, and we put this is some text inside the p tags. So let's get a reference to that so we can mess around with it and change the text inside of it. So remember how we got a reference to our canvas element using document.getElementById. And remember, the document is an object, so that goes back to Document Object Model, or DOM API. So they provide a document object for you, and that comes with ready-made properties and functions that you can call on this object. So let's call it and get a reference to our text element. And if you recall, our text element was called myText. So we're just going to do this same line and just put myText where the ID goes. So let's go right here and hit enter a couple times. And now we're going to create a variable that will hold the reference. So type let, and then let's call this text equals, and then we need document.getElementById. So document, and it should pop up, dot get element by ID. Click that, and that's a function, so it needs parentheses, and it takes a string, and we know what that is, right? So it's just a string of text, and it's whatever you set the ID to be. So we set it to be myText. And then it's a statement, so semicolon. Now we have a reference. I'm going to scroll up here. Now we have a reference to our text. So hit enter. Now we're going to add another event listener to the window object, much in the same manner as we did the resize listener. So let's create a listener that'll listen for mouse clicks. So type window and then call the addEventListener function. And then open parentheses because it's a function. And now recall it takes the event you want to listen for and the function that you want to be called when that event happens. So when you do that, it gives you a list of events that you can listen for. So let's scroll down to the mouse area here. And there is a click event listener, but I want to just listen for when the user presses down on the mouse button. So that's called mouse down. Let's click there. And then type comma. And now we specify the function that we want to call when the mouse down event happens. So let's name that handle mouse down. And of course, we haven't written this yet, so it won't work right now, but we're about to define that function on the next line. So hit semicolon, because that was a statement. Now we're going to define the function handle mouse down. So function handle mouse down. And it's a function, so it takes parentheses. And this function doesn't really need any parameters, so we can skip that and just go on to the next line. Opening curly brace, so left curly brace, and it'll close it up for you, and then hit enter. And now let's define this function, what we want to happen when the user presses down on the mouse button. Let's change the text that's in my text. So how we do that in JavaScript is we use our reference, which is called text, and then we update one of its properties called inner HTML, and that is what is displayed in the browser for that element. So type text dot, and one of its many properties is inner HTML. You can click there, see it says property. So, and it's not a function, so it doesn't take parentheses, but it's a property, so we can use the equals sign to assign a value to it. So equals, and now we can put in whatever we want to show up in the browser for that little text element. So, and recall it is a string, so it needs quotes. So quotes, and let's just say you pressed the mouse. And it's a statement, so we end it with a semicolon. Okay, let's see if that works. Okay, so we have our rectangles here, and we have our text element that says this is some text. Now I'm going to click the mouse. Let's see what happens. All right, cool. You press the mouse. But I notice a problem. I'm clicking the mouse over and over again, and it doesn't go away. Like when I don't click the mouse, it should go back to what it was, right? So let's add that in now, and so we'll make it even more responsive. So this is one of those instances in programming where you can copy and paste code. So let's try this. Window, all the way down through this function, through the right curly brace, and then control copy. The next line, maybe one more, enter, paste, control V. Now all we have to do is change it to mouse up. So when the user lets go of the mouse button, that's called mouse up. And then we can change the text back to what it was saying before. So let's change this to mouse up. And likewise, we don't want to call the handle mouse down function. That would be wrong. So let's do handle mouse up. And we have yet to define that function. So now we will define that function, erase down here as well, and type the word up. And then let's just make the text go back to what it was before. So this is some text. So you can select all that in between the quotes, backspace, and then this is some text. Okay, so now when the user clicks down, this message will pop up. You press the mouse. But when the user lets go of the mouse, that's called a mouse up, and the window is also listening for that event. And when it detects that, it'll call this function, handle mouse up. It'll go right here and execute whatever is inside this function. So that turns it back to this is some text. So now let's see the finished product. Okay, I got my rectangles. I can resize the window. Full screen again. And now I'm going to click the mouse. You press the mouse. Now I'm going to let go of the mouse. All right, it went back. That's pretty cool. So now we can just click all over the place, and no matter where we click on the page, it'll detect that event. So click down, up, down, up, down, up. No matter where I click the mouse, it works, because we're using the entire window to listen for the event. So one last thing to mention before we end for today is that I made a slide of the instructions for enabling the DevTools and the developer menu inside of Safari for Mac users. And so here it is. And I'll go ahead and add this to our GitHub repository that matches this video series, so that if there's anyone using the Safari browser out there to follow along with me on this video series, they can quickly see how to get their developer tools enabled, and so they can access the JavaScript console inside the Safari browser. Wow, we did a whole lot of things today, didn't we? All the way from opening up the DevTools inside our browser to get to the JavaScript console, to taking my patented whirlwind tour of the JavaScript programming language, and finally to adding event listeners to our web page using our new knowledge of JavaScript to make our web pages more responsive and interactive. And although we just barely scratched the surface of the JavaScript programming language and what it can do in the browser, I've found over the years that I only need a small subset of the JavaScript language in order to write my ray tracers, no matter how complex or fancy the ray tracers may be. So after today's episode, if you still don't quite understand how JavaScript works, don't worry, because as we write JavaScript for our future projects, we'll only use that small basic subset of the language. And we'll just use the basic elements of the JavaScript language to get the graphics up on screen that we need to. On the next episode, I'm going to show you how to create your very own repository on GitHub. And I'll do that on camera here so that you can follow along with me and so you can see exactly how it's done. And we'll see how easy that is with a new feature from VS Code, and one more reason to love VS Code, and that you can create a repository on GitHub without even leaving the environment of VS Code. And the cool thing about making your own GitHub repository is that you can easily share your ray tracing projects and demos that we'll be making here on this series. So I'm really looking forward to showing you how to do that on the next episode. So until then,